Article 501.3b2 of the National Electrical Code addresses storage batteries installed in hazardous or classified locations, stating that they must be located in an enclosure and ventilated according to Table 501.3d. This table specifies the ventilation requirements for enclosures based on the group classification of the hazardous material present. For Group A, B, C, and D, which cover a wide range of flammable gases and vapors, the enclosure type required is an increased safety enclosure. The ventilation requirement for this type of enclosure is that it must be ventilated to prevent the accumulation of flammable vapors. Based on these NEC code requirements, a battery enclosure situated in a Zone 2, also known as Class 1 Division 2, hazardous area should be of the increased safety type, designated as E. This designation implies that the enclosure is specifically designed to prevent the ignition of flammable vapors that may accumulate inside. The design incorporates features that minimize the risk of sparks, arcs, or hot surfaces that could potentially ignite a flammable atmosphere. An uncertified enclosure that does not have proper certification indicating that it meets the requirements for an E-type enclosure would not meet the NEC code requirement. Therefore, it would not be considered acceptable practice in North America for use in a Class 1 Division 2 hazardous location. To comply with the NEC code, the uncertified enclosure should be replaced with an XE-type enclosure. The enclosure should also incorporate XE-type terminals. These terminals are specifically designed to protect the connections from potential sparks or ignition sources, adding an extra layer of safety to the installation. Furthermore, it is essential to recognize that the local inspector in Australia may have additional requirements beyond the NEC code. Compliance with local regulations is crucial for ensuring the safety and legality of the installation. Therefore, it is advisable to consult with the local inspector to confirm that the installation meets both the NEC code and any local regulations that may apply. In summary, the NEC code mandates that battery enclosures in Zone 2 Class 1 Division 2 hazardous areas must be in XE-type enclosure equipped with XE-type terminals. An uncertified enclosure does not meet the NEC code requirements and is therefore unacceptable for use in these environments. It is essential to consult with the local inspector to ascertain any additional requirements that may apply. Let's delve deeper into the specifics of the NEC requirements for battery installations in hazardous locations, particularly focusing on Class 1 Division 2 areas. We'll examine the relevant articles and tables within the NEC to provide a comprehensive understanding of the code's intent and application. Firstly, it is crucial to understand what constitutes a hazardous location under the NEC. A hazardous location is an area where fire or explosion hazards may exist due to the presence of flammable gases, vapors, dusts, or fibers. These locations are classified into different classes, divisions, and zones based on the nature and likelihood of the hazard. Class 1 locations are those where flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 2 locations within Class 1 are those where flammable gases or vapors are handled, processed, or used, but are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. Zone 2 locations are equivalent to Division 2 locations under the Zone Classification System, which is an alternative method of classifying hazardous locations. The NEC provides specific requirements for electrical equipment and wiring in hazardous locations to minimize the risk of ignition and explosion. These requirements are outlined in Article 500 through Article 516 of the NEC. Now, let's focus on Article 501.3b2, which specifically addresses storage batteries installed in hazardous locations. This section mandates that storage batteries must be located in an enclosure and ventilated according to Table 501.3d. This requirement is in place to prevent the accumulation of flammable gases such as hydrogen, which can be released by batteries during charging or discharging. Table 501.3d provides detailed specifications for ventilating enclosures for storage batteries, depending on the group classification of the hazardous material present. The group classification refers to the specific type of flammable gas or vapor that may be present in the area. Common group classifications include A, B, C, and D, each representing different types of flammable substances. For group A, B, C, and D locations, the table requires the use of increased safety enclosures. Increased safety enclosures are designed to prevent the ignition of flammable gases or vapors by incorporating features that minimize the risk of sparks, arcs, or hot surfaces. These enclosures are constructed with materials and methods that ensure a high degree of protection against the ingress of flammable substances. The ventilation requirements for increased safety enclosures mandate that they be ventilated to prevent the accumulation of flammable vapors. This ventilation can be achieved through natural or mechanical means, depending on the size and design of the enclosure and the specific requirements of the installation. It is important to note that the ventilation system must be designed to effectively remove any flammable gases that may be released by the batteries, preventing them from reaching concentrations that could pose a fire or explosion hazard. In addition to the enclosure and ventilation requirements, the NEC also addresses the specific requirements for terminals and other electrical components within the battery enclosure. These components must be designed and installed in a manner that minimizes the risk of ignition. For example, terminals should be protected against accidental contact and should be constructed of materials that are resistant to corrosion and degradation. Wiring connections should be made using approved methods and should be properly insulated to prevent short circuits or ground faults. Furthermore, the NEC requires that all electrical equipment installed in hazardous locations be listed and labeled for the specific location and hazard involved. This listing and labeling process ensures that the equipment has been tested and certified to meet the applicable safety standards. It also provides assurance to inspectors and users that the equipment is suitable for use in the intended environment. In the case of battery enclosures in Class 1 Division 2 locations, the enclosure should be listed and labeled as suitable for use in Class 1 Division 2, Group A, B, C, or D locations, as applicable. The listing and labeling should also indicate that the enclosure meets the requirements for increased safety enclosures. It is essential to consult with the manufacturer of the battery enclosure to ensure that it is properly listed and labeled for the intended application. The manufacturer can provide documentation and technical information to support the listing and labeling claims. In addition to the NEC requirements, it is also important to consider any local regulations or codes that may apply to battery installations in hazardous locations. Local regulations may impose additional requirements or restrictions that are not covered by the NEC. It is the responsibility of the installer to ensure that the installation complies with all applicable codes and regulations. Consulting with the local electrical inspector is a crucial step in ensuring compliance. The inspector can provide guidance on the specific requirements that apply to the installation and can help to identify any potential issues or concerns. In summary, the NEC provides a comprehensive set of requirements for battery installations in hazardous locations, particularly Class 1 Division 2 areas. These requirements are designed to minimize the risk of ignition and explosion by ensuring that batteries are properly enclosed, ventilated, and protected. Compliance with the NEC and any applicable local regulations is essential for ensuring the safety and legality of the installation. Remember to consult with qualified professionals and local authorities to ensure that the installation meets all applicable requirements. Furthermore, the specific type of battery being used plays a role in determining the appropriate enclosure and ventilation requirements. Different types of batteries, such as lead-acid, nickel-cadmium, or lithium-ion, have different characteristics and may release different types and quantities of gases during charging or discharging. The NEC addresses the specific requirements for different types of batteries in Article 480, which covers storage batteries. This article provides guidance on the selection and installation of batteries, as well as the ventilation and safety requirements for battery rooms and enclosures. For example, lead-acid batteries release hydrogen gas during charging, which is a flammable gas. Therefore, lead-acid battery installations typically require more stringent ventilation requirements than other types of batteries. Lithium-ion batteries, on the other hand, may release flammable electrolytes or gases under certain conditions, such as overheating or overcharging. Therefore, lithium-ion battery installations may require additional safety measures to prevent thermal runaway or other hazardous events. It is crucial to consult with the battery manufacturer to determine the specific ventilation and safety requirements for the type of battery being used. The manufacturer can provide detailed information on the gases released by the battery, the recommended ventilation rates, and any other safety precautions that should be taken. In addition to the type of battery, the size and capacity of the battery installation also affect the ventilation requirements. Larger battery installations typically require more ventilation than smaller installations, as they are capable of releasing larger quantities of flammable gases. The NEC provides guidance on calculating the required ventilation rates based on the size and capacity of the battery installation. This calculation takes into account the type of battery, the charging rate, and the ambient temperature. It is essential to perform this calculation accurately to ensure that the ventilation system is adequate to prevent the accumulation of flammable gases. The design and installation of the ventilation system should also take into account the specific characteristics of the hazardous location. For example, if the location is subject to high winds or other environmental factors, the ventilation system should be designed to prevent the ingress of flammable gases from outside the enclosure. The ventilation system should also be designed to prevent the accumulation of flammable gases in low-lying areas or other confined spaces. Regular inspection and maintenance of the battery enclosure and ventilation system are essential to ensure their continued effectiveness. The enclosure should be inspected for any signs of damage or deterioration, such as cracks, corrosion, or loose connections. The ventilation system should be inspected to ensure that it is operating properly and that the ventilation rates are within the specified limits. Any deficiencies or issues should be addressed promptly to prevent potential hazards. Furthermore, personnel working with batteries in hazardous locations should be properly trained on the potential hazards and the safety precautions that should be taken. This training should include information on the types of gases released by batteries, the flammability characteristics of these gases, and the proper procedures for handling and maintaining batteries in hazardous locations. Personnel should also be trained on the use of personal protective equipment such as safety glasses, gloves, and respirators as necessary. In conclusion, battery installations in hazardous locations require careful consideration of the NEC requirements, local regulations, battery type, battery size, ventilation system design, inspection and maintenance, and personnel training. By addressing these factors, it is possible to ensure the safe and reliable operation of battery systems in hazardous environments. Remember that this information is for general guidance only and should not be substituted for professional engineering advice. Always consult with qualified professionals and local authorities to ensure that your installation meets all applicable requirements. The NEC is a living document that is updated regularly to reflect changes in technology and safety practices. It is essential to stay up to date on the latest version of the NEC to ensure that your installations comply with the most current requirements. The NEC is available for purchase from the National Fire Protection Association and other authorized distributors. It is also available for review at many public libraries and technical schools. In addition to the NEC, there are other industry standards and guidelines that provide valuable information on battery installations in hazardous locations. These standards and guidelines may be developed by organizations such as the Institute of Electrical and Electronics Engineers, the American Petroleum Institute, or the International Electrotechnical Commission. Consulting these standards and guidelines can provide additional insights and best practices for designing, installing, and maintaining battery systems in hazardous environments. Finally, it is important to emphasize the importance of safety when working with batteries in hazardous locations. Batteries can be dangerous if not handled properly. Always follow the manufacturer's instructions and the applicable safety codes and regulations. Use caution when working with batteries, and never take shortcuts or compromise safety. By prioritizing safety, it is possible to prevent accidents and injuries and to ensure the safe and reliable operation of battery systems in hazardous locations. Remember to always disconnect the power source before working on any electrical equipment, including batteries. Use insulated tools and wear appropriate personal protective equipment. Never smoke or use open flames near batteries, as they may release flammable gases. If you smell gas or see any signs of damage or overheating, immediately evacuate the area and call for help. By following these simple safety precautions, it is possible to minimize the risks associated with working with batteries in hazardous locations. These precautions are not exhaustive but provide a solid foundation for working with batteries safely. Be aware of your surroundings and always think before you act.